Good morning, grade 12 learners. Good morning, teachers. My name is Mohapi, and I'm working as a subject advisor for mathematics here in Mutao District. So today we've got a very, very interesting topic that we are going to deal with, and the topic is basically Euclidean geometry. Euclidean geometry, and as you know, Euclidean geometry is that topic that is a bit challenging to most of our learners, and the sad part is that this Euclidean geometry is part of paper 2. And out of paper 2, out of 150 marks from paper 2, this Euclidean geometry is going to take plus or minus 50 marks. So it is very much important that we really do our best in this topic. We cannot afford to make any mistakes at the moment. We need to stay focused and work hard on this topic. Challenging as it is, but we believe through practice, we'll be able to master this topic, and we'll be able to come up with at least 30 marks out of 50 marks based on this topic only. Okay, right? Remember today, my task is simple one, to try and take you through the bookwork. Remember, Euclidean geometry, it has got the bookwork. Basically, in bookwork in Euclidean geometry, we are referring to the proof of the theorems. Bookwork in Euclidean geometry refers to the proof of theorems. So I will take you through the proof of the two theorems in grade 12, namely the semi-proportionality theorem as well as the similarity theorem. Are you all ready now? Thank you. Let's start there. The first theorem in grade 12, remember, is the one that states a line drawn parallel to one side of a triangle. A line Thank you. A line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. That is the theorem. Let's analyze the theorem. And remember, when you analyze the theorem, we must be able to identify the required to prove part as well as the given part. A line drawn parallel to one side of a triangle. As you can see here, we're talking of a triangle. We are talking of a triangle. So let's draw that triangle. Let's say we are given triangle ABC. Let's draw. We've got a triangle there. So let's name it triangle ABC. A line drawn parallel to one side of a triangle. In other words, there must be a line, and that line must be drawn parallel to one side of a triangle. Let's mark off here. Let's say we've got point D there, and then we also have E there, and then we draw DE such that DE must be parallel to BC. We've got a line parallel to one side of a triangle. That line in this case is DE, and DE is parallel to BC. Remember, originally we had triangle ABC. So triangle ABC has got three sides, namely AB, BC, and AC. So the theorem states a line drawn parallel to one side of a triangle. So that line, in this case, it will be DE, which is drawn parallel to BC. The theorem states that line cuts the other two sides in the same proportion. It means this will then be the required to prove part. The required to prove part. What is the required to prove part? That line DE divides AB and AC in the same proportion. In other words, we've got to prove that AD over DB must be equals to AE over EC. That is the required to prove part. Let me start again. A line drawn parallel to one side of a triangle. We said we've got triangle ABC, and the line that is drawn is line DE, such that DE is parallel to BC. So the theorem states that line, which is parallel to one side of a triangle, it will divide the other two sides in the same proportion. So it means, you see, this AD, this point D, it cuts AB into AD and DB. The very same thing applies to point E, which cuts side AC in AE and AC. So this is the theorem. This is what we want to prove. We want to prove that AD over DB is equals to AE over AC. It's going to be very much interesting. We've got to relax and try to apply our previous theorems properly. The most important thing, we've got parallel lines here. So before we can start with the proof of the theorem, let's do some construction. Let's do some construction. The construction part. Thank you. In our construction, we're going to draw, height, let's name it K, relative to base AD, relative to base AD. Let me draw it so I can have a look at it. Let me draw it. Here is, we are going to draw height K relative to base AD. Here is base AD. Now I'm going to draw height K. Because its height, you indicate it's 90 degrees there, therefore this height is K. Now again, we are also going to draw height H relative to base AE. Let me draw height H so such that AE becomes the base. There we go. Now AE is the base because it's a height 90 degrees, and this one we denote by the letter H. Thank you. And then let's join DC and BE so that we should have areas between two triangles. Let's join BE and DC, then we can talk of the areas between the areas of triangles which lie between two parallel lines. Let's join with the aid of a ruler. You join. You join. Now we've got our triangle, we've got all our constructions clearly indicated. Now let's start with the proof. Remember the key thing here, the key thing when proving this theorem, is to know the area of a triangle. From junior grades, you knew that the formula that we use, you were taught that the formula that we use for determining the area of a triangle is half base multiplied by height. Half base multiplied by height. Then let's carry on with that formula then. Proof. Now we prove. Let's determine the area of triangle ADE and the area of triangle BDE. Please take note. I have chosen triangle ADE such that AD becomes the base, and we also have got triangle BDE such that BD will be on the baseline. So the height for both triangles will be K. Then let's prove area of triangle ADE. We are going to divide that by area of triangle BDE. Thank you. Let's work it out. This is equals to area of triangle ADE. Remember, area of a triangle, half base multiplied by height. So look at triangle ADE such that AD becomes our base. So the formula will then be half base. We choose AD as a base. So half AD times height. Height in this case will then be K. We divide by area of triangle BDE. So if look at triangle BDE, we choose BD as a base. So the area will then be half base. Our base is BD height. Height will then still be K because it's on that baseline, the line in which the base is found. So you try and simplify this. If you simplify this further, then you'll find that half will cancel half, half into half once, k into k once. So ultimately we are only left with what? We are only left with AD over BD. AD over DB. Thank you. In other words, what we have done right now is that the area of triangle ADE, you divide by area of triangle BDE, it gives you AD over BD. AD over BD. You remember why? Because half will cancel half, they've got the same height. They've got the same height, which is K. So K will cancel K, then ultimately we are only left with AD over BD. Let's carry on again. Let's come to this triangle now. The very same triangle ADE. The very same triangle ADE, but now we'll be comparing its height relative to triangle DEC. Thank you. Let's start. Let's carry on. Area of triangle ADE. You divide by area of triangle DEC. Let's check. Remember the formula that we use to calculate the area of a triangle? The formula is half base multiplied by height. The formula for calculating the area of a triangle, half base multiplied by height. Check the diagram. Triangle ADE. Now we choose our base as AE. AE is going to be our base. So the area of triangle ADE will be half base. Our base is AE times by height. Height in this case will then be H, because H is the one that is perpendicular to AE. Then let's write down the substitution. Area of triangle ADE, like I indicated, will be half. Our base will then be AE multiplied by our height is H. Then you divide by, check the area of triangle DEC. Triangle DEC. We choose base. Our base is we are going to choose EC as our base. So if EC is our base, what is the line perpendicular to the baseline? H. So it will then be half EC times H. Like we did with the previous one, we simplify that further. Half into half once, H into H once. Therefore, we are left with AE over AC. We are left with AE over AC. What is special here is that there are things that are a bit common. Check. We have been talking about the area of triangle ADE. Even here, it's still area of triangle ADE. So, something that is what is common. Area of triangle ADE is common in both cases. But check area of triangle BDE and area of triangle DEC. Remember the two triangles, triangle DEC and triangle DEC and triangle BDE. They are between the parallel lines. So if they are between the parallel lines, it means their height can be the same. And you can just decide to choose a common base. So what does that mean? It therefore means that area of triangle BDE, area of triangle BDE is equals to area of triangle DEC. Learners, I'm talking about, look, we've got DE, which this side DE, which is parallel to BC. So the two triangles, they are between the parallel lines. So if the two triangles are between the parallel lines, they can have the same height. And depending, if we can choose DE as a base for both triangles. Check triangle BDE, you can choose DE as a base. Check triangle DEC, you can choose DE as a base. So they can have the same base. Because they are between parallel lines, the height will also be the same. So they've got the same base and same height. That's why we say the area should be the same. Area is equals to half base multiplied by height. So now we are having two triangles in which The two triangles have got the same base and the same height. That's how we conclude that their areas are the same. That's why here I said area of triangle BDE is equals to area of triangle DEC. The reason will be the two triangles have got the same base and height. Same base and height. Because they lie between parallel lines. They've got the same base and same height. Thank you. Let's go back to our ratio. Remember, area of triangle ADE over area of triangle BDE, it was AD over BD. Area of triangle ADE over area of triangle DEC, it was AE over AC. And in the two statements, triangle ADE is common in both. ADE, ADE. And the area of triangle BDE and the area of triangle DEC, they are the same. They are equal. Why do we say they are equal? Because the two triangles lie between parallel lines. If they lie between parallel lines, they've got the same base, which can be DE, and height, because they are between parallel lines. Then let us conclude there. Check our conclusion. Therefore, this means that if I conclude based on the two statements, this will then be the conclusion. Area of triangle ADE, you divide it by area of triangle DBE. DBE be equals to area of triangle ADE, area of triangle ADE. You see triangle ADE, triangle ADE. Instead of triangle DBE, now we write area of triangle DEC, because area of this triangle and that one, they are equal, like I showed you earlier. Now we conclude. Remember from our workout, area of triangle ADE divided by area of triangle BDE, we had AD over BD. We had AD over DB. Therefore, this one is the same as AD over DB. Check area of triangle ADE. Let me bring back again. Area of triangle ADE divided by DEC. Area of triangle ADE divided by DEC, we had AE over AC. Here we are. Area of triangle ADE divided by area of triangle DEC, we are left with AE over AC. Thank you. See, still remember the required to prove part. If you can check this, this is basically what we are required to prove. Required to prove AD over DB is equals to AE over EC. Required to prove. Required to prove. AD over DB is equals to AE over AC. After that workout, then we have ultimately come to the conclusion. We have proven the theorem. So it means, remember, a theorem is a statement that can be proved to be true. So now we know, from now onwards, we know very well that a line drawn parallel to one side of a triangle will cast the other two sides so as to divide them in the same proportion. That is the theorem that I wanted us to prove for now. The theorem here it is. Let me show you the theorem. It states a line drawn parallel to one side of a triangle, cast the other two sides so as to divide them in the same proportion. Clear? Please, teachers, take our learners through this slowly, give them a time to practice, because there is a very huge possibility that this theorem can be in the paper. And in most cases, you see in grade 12, basically the main two theorems for grade 12 is only the similarity theorem and the proportionality theorem. So definitely one of the two theorems, the chances of one of them be asked in the examinations, I think it will be around 85% possibility. So we need to make sure that we prepare our learners thoroughly for this proof. Thank you. The theorem that we did, a line parallel to a side of a triangle, cast or divide, a line drawn parallel to one side of a triangle, cast the other two sides of a triangle so as to divide them in the same proportion. Let me take you some few examples whereby we try and apply the theorem. Thank you. Check this. Thank you. Check that. In triangle ABC, hope it's clear. In triangle ABC, DE is parallel to BC. So that is the given information. We have triangle ABC. And what is given is that DE is parallel to BC. What is important again when solving Euclidean geometry, you need to try by your level best to make sure that all the information that is given, you indicate it on the diagram. The information that is given, indicate that information on the diagram. Thank you. Let me start again fresh. In triangle ABC, here's triangle ABC. DE, here is the dotted line. DE is drawn parallel to BC. This is given information. So what is important, once you have the given information, you indicate that information on the diagram. I said we're trying to apply the theorem. Remember the theorem that states a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. So the exercise that we are trying to do right now is that, like, it's given that in triangle ABC, DE is parallel to BC. So once that is given, indicate the given information on the diagram. Now we have indicated that DE, here it is, DE is parallel to BC. It's given that AB, check AB, AB is equal to 28 millimeters. It means the length of this, the whole thing. The whole side AB, the length is 28 millimeters. AB is 28 millimeters. Then we are also given the ratio. AE is to EC is 4 and 3. AE is to EC. AE here is AE. You can see the ratio there is 4. EC, the ratio there is 3. Thank you. The question then states, determine the length of BD. Here is BD. There is BD. We need to determine the length of BD. What is key in this case is to take your given information and make sure that this, the unknown, can just first start with the unknown. In this case, we have been tasked to determine the length of BD. Thank you. Remember, the length of AB as a whole is 28 millimeters. But the ratio of AE is to EC is 4 is to 3. We're not saying AE is equal to 4 millimeters. We are not saying EC is equal to 3 millimeters. No, the ratio of AE is to EC is to 4 by 3. So if you take the ratio of AC is to EC, let me just say the ratio of AC is to EC, just for an example. Check, the ratio will then be equals to AC, 4 and 3, will then be 7. AC, the whole of AC, 7 is to EC, 3. Do you see where does this 7 come from? AE is to EC, 4 is to 3. But if you talk of AC is to EC, then the ratio will then be 7 is to 3. Now check. What do we want to go? What is the question? The question states, determine the length of BD. Here is BD. BD. Remember the theorem. A line parallel to a side of a triangle divides the other two sides so as to cut them in the same proportion. A line parallel to a side of a triangle. A line drawn parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. So it means they are in the same ratio. DE is parallel to BC. What does that mean? It tells us AD over DB is equal to AE over EC. Not only that, ratio can be taken differently. You can also say BD over AB. You see, BD over AB. In this side, we'll then say EC over AC. Let's work it out. Let me take BD over AB. Check the order. Please check the order. Order is very much important. If you take BD here, BD over AD. BD over AD. So BD, then on this side we'll have EC, and EC over AD. This side will then take AC. The order is important. Let's substitute. BD over AB. Remember, our AB is 28 millimeters. Over 28 will be equals to EC, the ratio is 3. AC, the ratio 7. So what do? We multiply both sides by 28 so that we should only be left with BD. Let's multiply this side by 28. What you do on the left, you also do on the right. You also multiply this side by 28. So that 28 cancels 28, you are only left with BD. In this case, 3 over 7, you multiply by 28. You say 7 into 7 once. How many times does 7 goes into 28? 28 divided by 7. Work it out. You don't have to use a calculator. 7, 14, 4 times. So 7 in here goes once, here goes 4 times. So 3 multiplied by 4, then 12. So it therefore means BD is equal to 12 millimeters. Let me take you through the question again, slowly. It was given that in triangle ABC, DE is parallel to BC. DE parallel to BC. I said to you, it is important to mark the given information on the diagram, indicated on the diagram. So I've indicated that DE is parallel to BC. Furthermore, what is given is that AB, check AB, is 28 millimeters. AB is 28 millimeters. Check the ratio of AE is to EC. The ratio of AE is to EC. The ratio is 4 is to 3. I have indicated all the information on the diagram. The question states determine the length of BD. Now I want to determine the length of BD. So we've got different approaches. What others will then prefer to say, now if you want BD, let's take BD over AD. Because you already know AD, the BD is the only unknown. So you take BD over AD. That order will also apply on the other side. So if you take BD here, you'll take EC. If you take AC, there you'll take AB, there you'll take AC. That's why we have BD over AB is equals to EC over AC. Now we substituted. BD, here is BD. Our AB is 28 millimeters. EC is 3, AC 7 in terms of ratio. Then we multiply by 28 both sides so that we should only be left with BD on the left hand side. So you multiply by 28, 28 cancel 28, you are only left with BD. 3 divided by 7, multiply by 28, we end up with our answer as 12 millimeters. Interesting, man. Interesting. What I need to emphasize is that the order is very much important. The theorem only states a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. So it depends on you as a learner. Which ratio do you want to work with? If in this case you want to work with AD over DB, that side you'll say AE over EC. The order is very much important. The order in which you take your proportionality is very much important. This theorem is called the proportionality theorem because a line drawn parallel to one side of a triangle cuts the other two sides so as to divide them in the same proportion. It's a proportionality theorem. So the order is very much important in this case. Thank you. Right now I'm going to give you an exercise. Please, I think this exercise, it will take you about 5 minutes to do the exercise. I'm going to give you 5 minutes to do the following exercise. Once you've got the solution, I will then indicate, we'll then work it out together to find what the solution. Thank you. Here is the exercise that I want to give to you. Can you do that one? Thank you. What is given in this case that in triangle ABC, BF, in triangle ABC, AB is parallel to FD. AB is parallel to FD, and it's already marked. I like it. AB is parallel to FD. It's already marked. And AF parallel to DE, it's also already marked. You are given the ratio of FE is to EC. Check, FE is to EC. The ratio that is given there is 3:4. FE is to EC, the ratio is 3:4. The question states, determine the ratio EC. EC is to BC. EC is to BC. I'm going to give you about 5 minutes to find the solution. Thank you. In 5 minutes time, we'll then carry on with the solution. Thank you. Welcome back. Welcome back. I hope you've worked it out, and let's see whether the answer that you got will correspond with mine. Remember what I said earlier. What is important is that to indicate the given information on the diagram. That is the most important thing. To indicate the given information on the diagram. So in this case, fortunately, the information is already been indicated. Let's see. In triangle ABC, AB is parallel to FD. AB parallel to FD is marked. Thank you, it's already indicated. AF parallel to DE, also already marked. The ratio of FE is to EC. FE is to EC. The ratio is 3:4. The ratio here is 3. The ratio there is 4. Remember, we're not saying FE is equal to 3 units, EC is equal to 4 units. That is not the implication. With the implication that the ratio of FE is to EC is 3 and 4. So what is the question? Determine the ratio of EC. EC, we already have, fortunately, is to BC. Is to BC. So the problem is that we don't have BC. Let's work it out. Let's work it out. Let's apply the very same theorem that states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Maybe I should hide something here. Maybe I should hide something here. Check. What do you have? See, you've got DE that is parallel to AF. DE parallel to AF. A line parallel to a side of a triangle cuts the other two sides in the same proportion. Can you see that? Thank you. Then we can say FE over EC will then be the same as AD over DC, because DE is parallel to AF, and that is the given information. So we apply the proportionality theorem. We say FE divided by EC is equals to AD over DC. I said the order is important. That is the order that I want you to take. Thank you. We say FE over EC is equals to FE over EC is equals to AD over DC. Remember, we are busy with the Euclidean geometry, and you always have to provide a reason. Why do I say FE over EC is equals to AD over DC? Always provide the reason. And in this case, the reason will be a line parallel to a side of triangle. We know that a line drawn a line drawn parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. It's because of that theorem that we have just proven, and then now we are applying it right now here. And check, FE over EC, we've got it. FE over EC is given to us as 3 over 4, which is equals to AD over DC. Thank you. What does that tell you? It means the ratio of AD over DC is also 3 over 4. Let's indicate it. It's also 3 over 4. Our task, we want BC, because EC we already have. The question states, determine the ratio of EC. Here is EC we already have. BC. BC we don't have. So for us to have BC, we need to have BF. Thank you. Look at this bigger triangle ABC in the bigger triangle. Triangle ABC. In this bigger triangle ABC, if you take AD over DC, let me write it down. In triangle ABC. In triangle ABC, we take AD over DC. AD over DC is equals to, if you take AD over DC, you'll take BF over FC, because you've got this line, which is parallel to one side of a triangle. You've got DF, which is parallel to AB, and AB is a side of triangle ABC. So, AD over DC will be equals to BF over FC. Order is very much important. AD over DC, BF over FC. Thank you. Check AD. What is the ratio of AD? AD here we've got 3 over DC we've got 4, which will then be equals to BF. We don't know. We don't have the ratio of a BF. Let's leave it as it is. It's BF over FC. FC 3 and 4, they give us 7. 3 over 7, the ratio. Now, what do we need to do? We need to solve for BF. To find the value of BF, we multiply both sides by 7. Let's multiply by 7 here. What you do on the right, you also do on the left. Thank you. Then ultimately, you've got BF. You multiply the 7, multiply by 3 will give you 21 over 4. Thank you. That is the ratio of BF. The ratio of BF, let's indicate it. This one will then be 21 over 4. 21 over 4. Now, let's answer our question. The question states, determine the ratio of EC. Remember, we've got EC, it's 3. But BC, we don't know the ratio. So to have the ratio for BC, we add 4, 3, and 21 over 4. We added those 3. Let's add them together. 3 plus 4 give you 7. 7 you add it to 21 over 4. What answer do you get? 7 you add it to 21 over 4. Let's check. It therefore means, what it means is that BC is equals to, if I take from the diagram, 21 over 4 plus 3 plus 4. Let me add it. 21 over 4 plus 3 plus 4. Let's add it together quickly. It's going to 3 and 4 give you 7. It's going to be 21 over 4 plus 7. It's over 1. Look for LCD quickly. Our LCD here will be 4. 4 into 4 once multiplied is going to be 21 plus 1 into 4. 4 times 4 multiplied by 7. I think it will give you 28. So that ultimately BC will be equal to 21 plus 28 will give you 49 over 4. 49 over 4. So that will be the total length, BC. BC ultimately is equals to 49 over 4. Clear? Because for us to find BC, we had to add to BC. Here is BC. For us to get BC, 21 over 4 plus 3 plus 4. And if you add the 3 numbers, they give us 49 over 4. That's why we say BC is equals to 49 over 4. Thank you. Now we can answer the question. Let's answer the question. The question states, determine the ratio, determine the ratio of EC is to BC. Now let's write down the answer there. Quickly, let me try and work it out. If we answer the question, we'll then say EC over BC will be equals to, remember EC we said it's 4, BC we said it will be 49, or maybe I should write 4 divided by 49 over 4. You still remember the length of BC, the whole BC we said it's 49 over 4. Let me show you. BC 49 over 4. So if we work it out further, we say here it is. I'm sorry for that inconvenience a bit. Sorry for that. EC over BC is 4 divided by 49, and according to the laws of fractions, it means it over 4 over 1 you multiply by 44 over 49. Multiply together, we've got 16 over 49. This is the ratio. This is the ratio of EC over BC. Thank you. Ultimately, that will be our final answer. EC divided by BC. EC is 4 divide BC is 49 over 4. So it's the same as 4 over 1 multiplied by 4 over 49. Because if you've got division, you need to change division to multiplication. That's the rules or the law of mathematics governing fractions. So we've got 4 over 1 multiplied by 4 over 49. 4 by 4 gives us 16 over 49. This will be the ratio EC over BC is equal to 16 over 49. Interesting. Thank you. Let's carry on with some more exercises. One more exercise. I hope 5 minutes will also be enough, and you will enjoy this one as well. Check exercise 1. In that exercise 1, I want you to do number 1 for me. In triangle PQR, ST is parallel to QR. Calculate the value of Y. Everything is indicated on the diagram. Calculate the value of not Y. Basically, we need to calculate the value of X. Can I rectify that? Sorry, you need to calculate the value of X. In triangle PQR, ST parallel to QR. Find the value, calculate the value of X. This is X. TR is X, PT is 10, PS is 5, and SQ is 2. For 3 minutes. Let me give you 3 minutes. Thank you. Go. Thank you very much. Thank you very much. Your time has elapsed. So let's check the solution. Check your work against mine. I gave you 3 minutes to work this one out. It was an easy exercise. Remember the theorem. A line drawn parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. That is very much important. And when applying the theorem, the order in which you take the sides becomes even very much more important as well. The order in which you take your sides is very much important. Check. in triangle PQR, ST parallel to QR. Calculate the value of x. Here is x. Now we start with the ratio. If you take x over 10, very much important. X over 10, the order is important. I still want to maintain order is important. X over 10, 2 over 5 is equals to 2 over 5. Now for us to solve x, you need to multiply by 10 over 1. What do you do on the left, you also do on the right. 10 cancels 10, you are left with x. So you simplify there. 2 multiplied by 10 is 20, divided by 4. By 5, I think it will give you 4. So x will be equal to 4 centimeters. We include the units here because units have been given as centimeters. So it means x will be equal to 4 centimeters. That was an easy one. But that's how we start. We start with the easy one and then we proceed to the more challenging ones. Teachers, please let us be careful when coming to this proportionality theorem. Let's expose our learners to as many work as possible. Our learners must be able to solve these problems on their own. Thank you. For another 3 minutes again. For another 3 minutes, you do me this one. For another 3 minutes, do me this one. Sorry for a minute. For 3 minutes, so let's solve that one. What's indicated, what's given there is that in triangle ACE, BD is parallel to AE. Calculate the value of y. That is the value of y. There is y. Here is y. AB is y. We've got CD is 24. DE is 18 centimeters. AC is 35 centimeters. Your task is to find y. I think 3 minutes would be enough for you to go through the solution. I'm giving you 3 minutes again. Thank you. Welcome back, welcome back, welcome back. Now we're starting to enjoy Euclidean geometry. And remember, I said this topic in paper 2 will be out of 150 marks. Euclidean geometry is going to take plus or minus 50 marks. It's a lot of marks. You cannot afford to lose those marks. That's why I'm humbly requesting teachers, give learners lots and lots of exercises and take them through those solutions step by step. Thank you. Let's solve this one. In triangle ACE, BD parallel to AE. BD parallel to AE. Calculate the value of y. There is y. What is important is the order. Y over AC. I'm just taking y over AC. The very same order is again same. If you take y here, you'll take DE on this other side. You'll take DE over AC is the whole side. This side you'll take CE. CE. Let's substitute. Let's substitute y over AC is given as 35. DE. Check DE 18 over CE. CE, you add the 2. 24 plus 18. I think 24 plus 18 will give you 42. Definitely it will give you 42. 42. Now we solve for y. Let's multiply both sides by 35. What you do on the left, you also do on the right. Thank you. Now 35 will cancel 35. You are left with y. Check 18 over 42. Multiply by 35. I can see you're already rushing to your calculators. You can work it out. Remember, it's a multiple. Basically, if you can take the multiple of 7. 7 into 35, common factor here. 7 into 35, 7, 14, yes, 28, 5 times. 5 times, and 7 into 42 goes 6 times. Now we can still even simplify it further to say 6 into 18 divided by 6. 18 divided by 6, I think, will give you 3. Then you have 3 multiplied by 5, which is equals to 15. What are the units used? Centimeters. Therefore, the value of y is equals to 15 centimeters. Teachers, my humble appeal, give learners lots and lots of exercises on this. Because through exercises, doing those exercises, they will become more and more perfect. Because in mathematics, we believe in practice makes perfect. Clear? That was the first theorem that I wanted to discuss with you, and the theorem is called proportionality theorem. And in proportionality theorem, that's the theorem that states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. I strongly believe later on today you'll also be exposed to exercises in Euclid geometry whereby we'll be combining all the grade 11 theorems, grade 10, grade 9 theorems together with these grade 12s. They'll be put together, but at the moment I'm only specifically focusing on the grade 12 theorems. The first theorem that I've done for today is the proportionality theorem, which states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Thank you very much. I think I can now go to the second theorem, and the second theorem is the one that is called similarity theorem. I know you did similarity in grade 10, so just have to carry on with the very same concept of similar figures. What do we mean when we say two figures are similar? Let me take you through the similarity theorem. The similarity theorem states the corresponding sides of two equiangular triangles are in the same proportion. Let me write it down. The corresponding sides of two equiangular triangles are in the same proportion. The corresponding sides of two equiangular triangles are in the same proportion. That is the theorem that I want us to prove together. Theorem, a statement that can be proved to be true. So the statement that is given is that the corresponding sides of two triangles, we talk of two triangles, the corresponding sides of two triangles, let me underline that, two equiangular triangles. Let me draw the two triangles. Let me draw the first triangle here. Let me call this triangle A, B, C. And I've got to draw another triangle, and the two triangles must be equiangular. Let me draw a triangle. And this triangle, I can call it triangle D, E, F. I have deliberately drawn the two triangles so that they shouldn't be of the same sizes. So what is the given information? It's given that the corresponding sides of two equiangular triangles. Equiangular triangles. What do we mean by equiangular? Equi from the word equal. Angular angles. Equiangular triangles means the corresponding angles of those two triangles are equal. Equiangular, equal angles. What does that mean? It means angle A is equal to angle D. Can you see that? Angle C is equal to angle F. Mark them same way because they are equal. We need to mark them in the same way. Then angle B, let me make a smaller circle. Angle B is equal to angle E. Thank you. That is what is given. We've got triangle ABC and triangle DEF such that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. That's the given. What are we required to prove? The theorem states the corresponding sides of two equiangular triangles are in the same proportion. It means the sides, if the two triangles are equiangular, their corresponding sides must be proportional. They must be in the same proportion. It means AB, which is the required to prove part, because we want to prove the theorem here. We want to prove the theorem required to prove part. We want to prove that AB over DE is equals to AC over DF. Order is also important. You can even go further and say BC over EF. That is still acceptable. But for examination purposes, we believe we'll only have that one. Just to prove two pairs of sides to be proportional. But in reality, the three sides, all the sides are proportional. If the corresponding sides of two equiangular triangles are in the same proportion. If two triangles are equiangular, then their corresponding sides are proportional, meaning that AB over DF is equals to AC over, let me start AB over DE. Let me be slow. AB over DE is equals to AC over DF is equals to BC over EF. So let's prove the first two pairs. We want to prove that in the two triangles, AB over DE, AC over DF. It means we want to prove that the sides are proportional because we are given that the two triangles are equiangular. Their corresponding angles are equal. So we want to prove the sides to be proportional. Clear? Let's construct. Sorry for that. Let's construct. Construction. Let's mark off AG on AB such that AG should be equal to DE. Let's mark AG such that AG is equal to DE with G on AB. Say it's G here, such that this side is equals to that one. Again, let's mark off again AH such that H is on AC. Mark off AH to be equals to DF. This side is equals to this one. So we have that. This is H here. That is H here. Let me call this angle B1. Thank you. Angle G1. Thank you. Then proof. What is that you want to prove? Remember the required to prove part. We want to prove that AB over DE is equal to AC over DF. Let me ask you a question. Look at this triangle AGH. Look at this triangle DEH. What can I say about the two triangles? What can you say about the two triangles? Triangle AGH, triangle DEF. What can you say about them? Thank you. Let's work it out. I think we have to prove congruency between the two triangles. Do you still remember the concept of congruency? Congruency, which means equal in all respect. Thank you. Let's go to in triangle AGH and triangle DEF. In the two triangles, I can firstly say AG. AG is equals to DE. Why do I say AG is equals to DE? It's because that is according to our construction. Remember, in our construction, we said we should mark off AG to be equals to DE. It's not the given information. It's due to our construction. Then the reason should be it's because of the construction. Because of the construction. AG is equals to DE because of the construction. Yes, you can give me the other one. Correctly so, AH is also equals to DF. Construction again. The reason is still construction. Because that is according to our construction there. We constructed AG to be equals to DE and AH to be equals to DF. That is according to our construction. For us to prove congruency, remember we must have three statements. Check in triangle AGH, we've got angle A, which is equals to angle D. This one, remember, this is the given information. It's not construction. Because the theorem, if two triangles are equiangular, then the sides must be proportional. It means the two triangles were equiangular. Triangle ABC and triangle DEF, they had their corresponding angles equal. Angle A is equals to angle D, B is equals to E, and C is equals to F. Hence, we have marked them similarly on the diagrams. We have marked them on the same way on the diagrams to show that they are equal. So, AG is equals to DE due to construction, AH, DF construction, then angle A is equals to angle D. Based on the three statements, then it means you can conclude the chart. We then conclude that triangle AGH is congruent to triangle DEF. Why do we say they are congruent? Still remember the conditions or the four cases of congruency. Side, pair of sides, the included angle, and another pair of sides. So the reason here will then be side, angle, side. The reason why we say the two triangles are congruent. And you still remember what we mean by congruency. Congruence means equal in all respect. It means triangle AGH and triangle DEF, they are equal in all respect. If the two triangles AGH and DEF are equal in all respect, it means their corresponding sides are equal, their corresponding angles are also equal. They are congruent. By congruency, we mean equal in all respect. Therefore, from congruency, we can then say angle G1 is equals to angle E. This G1 will then be equals to angle E. Remember the two triangles, triangle AGH and triangle DEF. We have proven that they are congruent. So if they are congruent, this angle A is equals to angle D, G1 is equals to E, side AG is equals to DE, side AH is equals to DF, side GH is equals to E. They are equal in all respect. So if they are equal in all respect, it therefore means angle E is equals to G1. Because it's from congruency, because we have proved that the two triangles are congruent. You still remember that? Yes, I can see some of you still remember from the given information. But you still remember that angle what? Angle B is equals to angle E. You still remember? BE. That was the given. This one is from the given information. Because the first statement said two triangles are equiangular. Two triangles are equiangular. By equiangular, it means corresponding, all the angles are equal. So it means angle A is equals to angle D, angle B is equals to angle E, and C is equals to angle F. So B is equals to E from the given. That is what was given. Two triangles were equiangular. But G1 is equals to E. This one, G1 is equals to E from congruency. From the two statements, we can draw another conclusion. Therefore, what can you conclude? G1 is equals to E. Angle B is equals to E. From the two statements, what can you conclude? Correctly so. Angle G1 is equals to angle B. Therefore, it means angle G1 is equals to angle B. Look at the two position of the two triangles. G1, B. G1, B. We said angle G1 is equals to B. Look at them. Angle G1, B. How do they relate? They are corresponding. G1 and angle B. These are the corresponding angles. And remember, corresponding angles will only be equal if they lie between parallel lines. G1, B. Those are the corresponding angles. And for them to be equal, it means the GH must be parallel to BC. Because corresponding angles will be equal if and only if they lie on parallel lines. We can have corresponding angles, but it does not mean that they are equal unless they lie on parallel lines. So in this case, we've got the corresponding angles that are equal. If the corresponding angles are equal, it goes without the word no that GH will, the two lines, GH will then be parallel to BC. Why? Because G1 is equals to B. And G1 and B are corresponding angles. And corresponding angles will only be equal if they lie on parallel lines. Thank you. Therefore, we conclude. Therefore, GH is parallel to BC. Therefore, GH parallel to BC. Let me show you the diagram. Therefore, it means we conclude that GH is parallel to BC. Do you still, should I indicate it? Let me indicate it in red so that you can see the conclusion that we have just now arrived at. Right now, we are at this stage. We say GH parallel to BC. GH parallel to BC. Look at that triangle. Look at that. Maybe I should hide this one for a minute. Look at that triangle. The theorem that we just did right now. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Recall the theorem. We just did it earlier on today. A line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. So in this case, what do we have? We have GH parallel to BC. To still remember the required to prove part, we've got to prove that AB over DE is equal to AC over DE. So if GH is parallel to BC, we conclude that AB over, check, AB over DE. AB, we conclude AB over, check the order, AB over AG. Check the order, AB over AG. AB over AG. Even on that other side, AC over AH. AC over AH. Can you give me the reason for that statement? What I have written now, remember, GH is now parallel to BC. Now I say if the two lines are parallel, AB over AH. AB over AH is equal to AC over AH. The reason, a line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. From the given information again, let's carry on. Check AB. We've got AB over AG. Instead of AG, AG is equal to DE. From our construction, AG is equal to DE. So I substitute AG by DE. AC over, instead of AH, AC over AH. Instead of AH, AH is equal to DF. Now I substitute AH by DF. And that is the theorem that we wanted to prove, that these corresponding sides of the two triangles are proportional. If two triangles are equiangular, then their corresponding sides are proportional. We have just proven that AB, check, the order is important again. AB over DE is equal to AC over DF. We are taking sides from two different triangles, from triangle ABC and triangle DEF. Remember, those two triangles were equiangular. Now we have proven that if they are equiangular, their sides are also in proportion, the same proportion. That's why we have concluded AB over AG, AB over DE is equal to AC over DF. That is the proportionality theorem, and I think that was the required to prove part. If you remember, check the required to prove that AB over DE is equal to AC over DF. It is very much important to know the proof of this theorem, because part of bookwork is this one. It's examinable. It can be asked to determine or to prove this theorem. I said grade 12, we've got those two main theorems, proportionality theorem and the similarity theorem. and I have proven them. Please make sure that you understand it, and so that you can also be able to prove this on your own. Because remember, I said there are 85% chances that one of the two theorems will be examined, either in the June examination, September examination, or in the final examination. Because in grade 12, these are the two major theorems. Thank you. I think we've done enough for today. But before I can let you go, I want us to do one last exercise. One last exercise, and I believe that exercise will be based on the application of this theorem. One last exercise, and the exercise will be based on the application of this theorem. Thank you. Here is the exercise. Thank you. I hope it's visible enough. Let me take you through it. O is the center of the circle. Here is a diagram. O is the center of the circle. AB is a diameter. AB is a diameter. Then already once it's given that AB is a diameter, then you know the theorem from grade 11, angle subtended by a diameter at the circumference of the circle is 90 degrees. Therefore it means P1 would be equal to 90 degrees. Already all such information, mark it immediately. Mark it immediately. Let me take you through. O is the center of the circle. AB is a diameter. AB, maybe AC, can I say AC is a diameter, not AB? The diagram is not drawn properly. AC, can I rectify that one? AC is a diameter, not AB. AB is a tangent. Here I've written it handwritten. AB is a tangent of the circle at A. So this AB is a tangent. AC is a diameter. Chord CP. Here's chord CP produced to B. What we prove that AP squared equals to PC multiplied by BP. Just the question, just like that. Slowly look at it. O is the center of the circle. Here is O, the center of the circle. AC is a diameter. Here is AC is a diameter. And if AC is a diameter, already you know that this angle must be 90 degrees. That angle must be P1. Angle P1 must be 90 degrees because it's an angle subtended by diameter. Chord CP produced to B. AB is a tangent to the circle at A. That's AB. It's a tangent. Once you talk of a tangent, I know there are three theorems that should come to our mind. Three theorems associated with tangent. Tan chord, tangent perpendicular to radius, and lastly, tangent drawn from the same points outside the circle are equal in length. But for now, let's look at this one. We want to prove that AP squared is equals to PC multiplied by BP. Thank you. Let's prove. For us to prove this, we need to choose two triangles first and prove similarity between the two triangles. Remember the theorem that we did earlier. If the corresponding sides of two triangles are equiangular, then those sides are proportional. If the corresponding side, the corresponding sides of two equiangular triangles are in the same proportion. The corresponding sides of two equiangular triangles are in the same proportion. So let's take two triangles and prove them to be similar. Let's take in triangle ACP and triangle, the smaller triangle, the ACP and triangle ABP and ABP. Let's prove the two triangles to be similar. And remember, to prove that two triangles are similar, you only need to prove two angles to be equal. Two pair of angles to be equal, because the remaining pair will automatically be equal. A triangle is a three-sided figure, three angles. If two pairs of angles are equal from the two triangles, automatically the remaining pair will also be equal. So let's find two angles that are equal in this case. Check. In triangle ACP, angle P1 is equals to 90 degrees. Angle P1 is equals to 90 degrees. Why do I say angle P1 is equal to 90 degrees? Because it's an angle subtended by diameter, or you can say an angle in the semicircle. Check angle P2. If P1 is 90 degrees, what will be the size of P2? Thank you. P2 will also be equals to 90 degrees. Why? Because P1 and P2, those are the angles on a straight line. So they both should add up to 180 degrees. So if P1 is 90, automatically P2 must also be 90. Thank you. Let's go. It means angle P1 is equals to angle P2. Both equals to 90 degrees. First statement. We want to prove in the two triangles, we want to prove them to be similar. And for them to be similar, we need to prove two corresponding angles, two pairs of corresponding angles to be equal. So the first pair, P1 is equals to P2, angle P1 is equals to P2. Secondly, remember AB is a tangent. Then you can see the tan chord. It means angle C will be equals to A2. Angle C will be equals to angle A2. Why? Tan chord theorem from grade 11. Tan chord theorem. Angle between a tangent and a chord is equal angle in the alternate segment. In full, the tan chord theorem states the angle between a tangent of a circle and a chord drawn from a point of contact is equal to the angle in the alternate segment. So, in the two triangles, in triangle ACP and triangle ABP, number one, P1 is equals to angle P1 is equals to angle P2, both equals to 90 degrees. Angle C is equals to A2. So check triangle ACB. We have talked of this angle 90. On this side is that 90. We have talked of this angle to be equal to that one. See, there is one angle that is remaining. So therefore, A1 will then be equal to angle B. Third pair of angles from two triangles. Therefore, those angles must be equal. Now we conclude. Therefore, triangle PCA is similar. Look at the sign for similar. PCA is similar to triangle P. Angle P goes hand in hand with P. Check angle C goes with A. Then you write A. Then A1 here will go with B. Why do I say triangle PCA is similar to triangle PAB? Because we have proven that angle. This is a condition for two triangles to be similar. Now that we have proven the two triangles to be similar, we can take sides in order. Let's take any two sides in order. Let's say if you take AP over PC, AP over PC. Sorry, I've taken PA or AP over PC. Check on that other side. PA, PB. Because if you take PA, even this side, that must be the ratio. This if you take PC, got PA here. PA or AP. Remember AP, PA, same side. Here is the side if I have to show you. PA or AP, same thing. Now you cross multiply. AP and AP will then ultimately give you, cross multiply, will then give you AP squared. It's AP multiplied by AP, and then here you multiply, then you've got PC multiplied by PB. And this is what we were required to prove earlier on. Prove that AP squared is equal to PC multiplied by BP or PB, same thing. Interesting exercise. For you to master this, you need to practice a lot. One thing that I want to highlight before I go is that two triangles will only be similar if they are equiangular. To prove that two triangles are similar, just prove two pairs of angles to be equal. Then the remaining pair will automatically be equal. And then the order is very much important, because when you have to choose the ratio, order plays a very important role. If the order was not okay, you are not going to end up with the the question that we are asked to prove. Very much important. Order is very much important. Like in this case, I said angle P1 is equals to angle P2, angle C is equals to A2, angle A1 is equals to all these angles on this side. This is triangle PCA. Triangle PCA. This other side, PAB, triangle PAB. P associated with P, C with A, and angle A with B. Order is very much important, because once you've taken the sides, those letters in order, then it becomes easy for you to prove that the ratio is the same. On that note, let me take the opportunity to wish you well, and I hope you will practice the Euclidean geometry very hard, because it takes lots and lots of marks. I did what I had to do today, the proof of the two theorems, and also show you the application a little bit. My humble appeal, don't give up. Work hard. Keep on practicing. Remember, practice makes perfect. In case you don't understand, if you've got questions, don't hesitate to go to your teacher. On that note, I wish you well and good luck. Thank you.